Okay, now let's look at exercise 2, okay, which is related to biot law. So now you have a current filament and it is carrying 5 ampere of current from 5 to 4. Okay, this is the length of the current filament and you have to find the magnetic field H at this point. Okay, so first of all you need to draw this one out. Okay, so I have recorded the important information from the questions. For example, the current is 5 ampere and the current filament is from 5 to 4 and you are required to find the magnetic field at this point. So first of all you need to draw the current filament. So since it is from 5, so this one will be the starting point and extend up to 4. Okay, please look at the blue drawing. So this is the current filament and the current flow in the positive Z direction. Next, let's look at the observation point, which is 137. So you can just estimate the 137 is somewhere here. 137. Okay, so what should appear in your mind when you need to use the biot law to find the magnetic field? These equations should appear in your mind. Okay, and we have to define each of the variable here one by one. So for the I, it is already given by the questions. Now is the R. Okay, before we find the magnitude of the R, we need to have some extra drawing in our diagram. So this extra drawing, I represent it by using the red pen. So this is your observation point. In order to find the magnitude of your R, first of all, you need to define vector R. Okay, so this is vector R. So vector R is a straight line, okay, that touch, okay, the observation point and also the axis that contains the current filament. Okay, so in this case, the length of the current filament start from here and end at 4. So in order to get a 90 degrees here, you need to extend the length, okay, of the current filament, okay, so that you will able to get or draw a straight line that form a 90 degrees with the line that connect the point P. Okay, so after you draw this line, you need to define the coordinate of this point. So this point, I will name it as a point T. Okay, so the point T, you are very sure that the point T has the coordinate of X and Y equivalent to 0. So you put 0, 0. As for the coordinate of Z, you just follow the coordinate of the observation point. Your observation point has coordinate Z of 7. So this one is also 7. Okay, this is very important. Okay, this is how you define the coordinate of point T. When you define the coordinate of point T correctly, you will be able to calculate the unit vector or the vector R correctly. Okay, so in order to get the vector R, I have to take the observation point. This is the coordinate of observation point. When I write it in this way by using this kind of bracket, it means that this is a vector. This is not a coordinate. If coordinate, I will use a round bracket. So when you represent 3 points by using this bracket, okay, it means the vector. So the vector from the observation point, okay, minus the vector of the source point. Okay, so this one will be the source point, point T. So when you minus it, okay, you will get X here and 3Y. 7 minus 7, you get 0. So this one will be your vector R. After you find your vector R, you can proceed to find the magnitude of vector R, which is square root 10, by taking the 1 square plus the 3 square here. So after you get the magnitude, the next step is to find the unit vector R. Okay, unit vector R will be, you divide the vector R with its magnitude, this one. Okay, so you have settled this magnitude of R, which is equivalent to square root 10. Next, we move on to alpha 2 and alpha 1. Okay, again we need to have extra drawing in our original diagram. I connect the ends of the current filament to the observation point, and if according to their coordinate, okay, this value is smaller than this value, so this point I label it as A and this point I label it as B. So alpha 1 is the angle that attached to point A, and it will be located outside the current filament. So I label it here as my alpha 1. As for alpha 2, it will be located inside, okay, touching the current filament. Okay, so this one will be alpha 2 linked with the point B. Now your job is to find the angle, okay, based on the concept of triangle here. Okay, so I redraw the diagram. Okay, this is point P. Okay, I redraw it in 2D because that will be easier for you to do the calculations. So this is point P, point T, and also point A. Okay, so the T and P, okay, the length is square root 10 because it has been calculated just now, and this is 12. Okay, so from -5 until here, okay, 7 plus 5, so you get 12. So this is the big triangle. Okay, so this angle can be found by using the tangent. Okay, opposite over adjacent, you get your alpha 1 equivalent to 165.24. Next, we move on to alpha 2. Alpha 2 is here, so I will focus on this small triangle, and again I draw it in 2D. Okay, this is point T, point P, and point B, and this is your alpha 2. Again, you use the tangent, okay, to find your alpha 2, and the alpha 2 is 133.49. Next step is to replace all the value that you have calculated into the general equation of biot-Savart's law. Okay, and for this one, this is the unit vector phi, and it is equivalent to dl unit vector dl cross product with the vector r. So this one depends on the direction of the current flow. So we have to check by our drawing. Current is flow in the positive z direction, so my unit vector dl will be z, and this r is taken from here. Okay, just now you have calculated it, right? Okay, next you perform the calculation as usual. As for this one, you need to cross product each of the term one by one. Z cross product with the y, z cross product with the x, zx, you get positive y. And when z cross product with the y, z cross product with the y, z cross product with the y, you are in the reverse direction, so you will get negative x here. Okay, so the value you can calculate it easily by using your calculator.